All right, today we are going to be talking about inequalities in one variable. What do we mean by this? Well, we've seen equations in one variable. An equation in one variable is something that looks like this. Maybe we have 2x plus, 3 is equal to, I don't know, 7. And we have to solve for x in this equation, right? So we know that we're going to be able to find an absolute solution for x because we don't have an x and y variable here, we just have an x variable. So we would subtract 3 from both sides, cancel that out. 2x equals 4. We'd say 2 times what is 4? Well, we know 2 times 2 is 4, so we know that the answer is going to be 2, but we would say, okay, we divide by 2, and we get an answer of x is equal to 2, and that would be our answer. Okay, we can do the same thing, except for, we could write an equation as an inequality. So this means the only answer that will work, the only answer to work in the equation is 2. 2 is the only thing that will make this true. So if we plug this in, plug our answer back in for x, 2 times, plugging this in, 2 plus 3 is equal to 7. See what we did there? We just put this 2 right in to check and see if we get a true solution. So let's see. 2 times 2 is 4. 4 plus 3. Does that equal 7? 7 equals 7. 7 equals 7 is a proof that when we plug the number 2 in, we get two sides equal to each other. And that's a check to prove that 2 is indeed the only value for x that will work. If we put any other value in, it would make this statement false, not true. All right, so now let's take a look at inequalities in one variable. Let's see. Let's say we had the same equation, 2x plus 3, and in this case we said something like is less than 7, right? All right, how do we solve this? Well, we actually can go about solving it like using the same kind of algebraic tools as if it were an equal sign there instead of an inequality. So let's do the same steps. We would subtract 3 from both sides, and we would get 2x is again equal to 4. Sorry, not equal to. In this case, it's less than 4. We'd still divide both sides by 2. And now we would have an answer. We'd cross off the 2's. We know that x is going to be less than 2. Well, what does that mean, and how does it differ from our original? We know 2, if we plugged in the number 2, it would give us 7, which would equal 7. Well, guess what? We're not allowed to use 2 as an answer anymore because this inequality is saying that the only answers that you're allowed to use for x are the numbers that when you plug them in, you will get a solution that is less than 7. Right? So let's give ourselves an example. Try. So this is saying the only answers to work in this inequality are less than 2, are numbers less than 2. Fine, let's try it. So let's give ourselves some examples. I'm going to rewrite the equation. I'm going to pick a number less than 2. So for example, we could use the number 1, or we could use the number 1.5. We could use 0. And maybe we would try 3 just to see what happens. Would that one work? We know it's not, but let's give ourselves some some kind of proof. All of these answers now are going to work because they're less than 2 when we plug them in. So let's rewrite 2 times, in this case, 1 plus 3. Is that going to be less than 7? Well, 2 times 1 is 2 plus 3. 2 plus 3 is 5. So 5 is less than 7. So that means 1 is a solution to the inequality. We just proved it because when we plugged 1 in, we got 5, which was less than 7. So that's true. What happens if we plugged in 1.5? What would happen? 2 times 1.5 plus 3. Is that going to be less than 7? Let's see. 2 times 1.5 is 3. 3 plus 3. 3 plus 3 is 6. 6 is less than 7. This is true also. So 1.5 is a solution. Same is going to be true for 0. But watch what happens when we plug in 3. 3 is bigger than 2. And we're saying we are only allowed solutions less than 2. Well, what happens if we plug in a solution bigger than 2? If we say, okay, pick a number bigger than 2, in this case 3. So we're going to go 2 times 3. I'm going to plug that number in and see what happens. Plus 3 is less than 7. 2 times 3 is 6. Look at what happens. 6 plus 3 is 9. 9 is not less than 7. So this is a big no-no. It is 3 is not a solution. 3 is not a solution in this case, in this inequality. So you have to notice the difference between dealing with an equation versus an inequality. Again, an equation has one answer, and in this case it happens to be 2. An inequality, because it's saying that the numbers, when we plug in for x, have to be less than 7. All of our answers that will work in this inequality have to be less than 2. If we plug 2 in, we would get 7, but that would make this statement false. All right? So where do we go from here? Well, when you're dealing with graphing with one variable, you can do it one of 2 different ways. We know that our solution was x is what? Less than 2. That was the inequality. All right, this was our solution, how we came up with it. Did the algebra, x is less than 2. There's one of 2 ways that you can do this. We kind of talked about this if you graph it like on a coordinate plane where you're dealing with x and y variables. So you know that this is x and this is y. So if we go over to the number 2, we know that that's the boundary, and we know that the boundary is not included because it's a strictly less than. It doesn't have this equal sign under it. This is not what we have. Okay. So instead, we have an x is less than 2, which means that all of the values, so these are all values here on this line, where the x value is indeed 2. So this is like 2, 0, 2, 1. Down here is like 2, -1. But all of these have a solution where the x value is 2. Okay, so this is really, the boundary is really literally at x equals 2, but the boundary is not included. Because when we talk about solutions, our solution set is values of x that are less than 2. And where does that show up? It shows up all over here. This entire side. If you go onto this side and you select points, you know, here you're going to have a point 0, 0. 0, 0, the x value is less than 2. Maybe over here you have a point -1, -3 or something. Well, that also has an x value less than 2, right? So all of your points for solutions end up on this side because these are all the spots where the x value is less than 2. Over here, everything on this side, the x values are all going to be bigger than 2. The y values could be less than 2 or equal to 2 or greater than 2. We don't really care about the y values because this equation is only worried about one variable. So the solution set is going this way, okay? Now, this is dealing with the solution in 2 dimensions, but sometimes you don't have to worry about 2 dimensions because you're only in our original equation that we had, 2x plus 3 is less than 7. We ended up with solving it and getting x is less than 2. And when we did that, you could graph it just on a number line dealing with x's, like a horizontal number line just deals with x's, and not draw the entire coordinate plane. So how does that look? Well, we usually mark some specific points, and we kind of go over to 2, and we put an open circle, because an open circle is the boundary when the boundary is not included. And then we're going to say, okay, where do all of our answers lie? Which direction? They're all going to be headed this way. Okay? They're headed this way, and you could go on forever in the, negative direction as long as the value is less than 2. Right, so that's graphing, solving a solution in one variable. Now, there is kind of a weird thing that happens, and I want to show you an example. It doesn't happen when you're dealing with equations, but it can mess things up when you're dealing with inequalities. So here's the last thing we'll talk about. Sometimes, say you have, let's give ourselves -2x plus 3 is less than 7. Okay, let's see what happens. Strange things occur. Strange things occur sometimes, not all the times, but sometimes with inequalities that you don't have to deal with when you're talking about just strict equations. Okay? We would go about starting off to solve this equation similarly. So we would subtract 3 from both sides. Nothing to worry about here. We get -2x is less than 4. Same as we got before. The only difference now is this is a -2. Okay. If you have an inequality, it doesn't matter if it's less than or greater than or less than or equal to or greater than or equal to, it doesn't matter. Here's the problem. When you multiply or divide an inequality, when you multiply or divide an inequality, let's see, by a negative number, you have to switch the sign as well. You have to change the inequality. So let's just make sure we understand what that's saying. We had something along the lines of like, we were at the point -2x is less than 4. Okay, so watch what's going to happen. We're going to divide both sides by -2. These cancel, and we end up with x. And instead of a less than, everything has to be negated. So this side we divide by negative, the other side we divide by negative, and we're kind of like giving ourselves dividing by a negative. We're dividing the symbol, the inequality, by a negative, I guess, if you want to look at that way. But we are also kind of saying like it's the opposite of what it was. So instead of this being a less than sign, because we divided by these specific negative numbers right here and right here, this was division by a -2. We have to, the sign switches. Sign switches, and we went from a less than sign to a greater than sign now over here, and this becomes x is greater than -2. So it actually changes the entire answer, okay, in multiple ways. If we were to graph this, on you got to know how to do both. You know that if we're graphing it on an xy plane, we go over to -2, kind of draw our dotted line. This is the dotted line at x equals 2. That's the boundary at -2, sorry. And then we are going to shade everything to the right of that because we are looking for things that are greater than -2. And all of the x values that are bigger than -2 are on this side. They're only going to be on one side of the boundary or the other, unless you have like a little, less than or equal to, then you could include the line here, but we don't have that. So our boundary line is dotted. We can't include it as part of the solution. All of our answers now are going to be greater than -2. Those are the things that are going to make this statement true. So if we go back to the original equation, which was like, what was it, -2x plus 3 is what, less than 7? And if we plug in a number bigger than -2, right? So let's think about this. If we plug in, let's say, let's put in the number 1. 1 is bigger than -2. So we get -2 times 1. We're just going to show that this works. Plus 3 is less than 7. I'm just picking any number for x that's less than -2 because that's what it says. Greater than -2, because that's what it says in our answer. That our answer, any value for x, will work as long as the x value is bigger than -2. 1 is bigger than -2. Do the math and see what happens. Well, you get -2 plus 3 is less than 7. -2 plus 3 is 1. 1 is less than 7. That works. If we were to try something that looked like a number smaller than -2, so let's try, if we did -2, x plus 3 is less than 7, and in here, let's say we plugged in a -10. That's less than -2. That's not greater than -2. So maybe I put a -10 in there. What would happen? I'd write -2 times -10 plus 3. Is that going to be less than 7? Well, when we multiply them together, a negative times a negative gives us a positive. So that's a positive 20 plus a 3, less than 7. So 23 is less than 7. Is that true? No, it's not. No, this is a big no. No, no, it doesn't work. The reason it doesn't work is because our answers for x have to be larger than -2. And we were able to come to that conclusion by when we divided by a negative, we also swapped the sign out. So last thing, if you're going to graph this on a number line, on a one number line, just with x, right? We've got a 0 here. And then, we're counting, kind of giving ourselves some reference. And you put your value, oops, what just happened here? Okay. When you put your value of, let's say, -2, it's an open circle because it's not included. And this time, in order to make it true, we're going this way. All your values have to be above -2 for this equation, for this inequality. This -2x plus 3 is less than 7 gave us an answer of x is greater than -2. So you could draw it like this, with this, one-dimensional number line with just the x, or you could draw it in 2 dimensions and kind of create a line with the x is -2, dot the line, and shade it all the way to the right. All right, so you're going to give some of these a try and see how it goes.